This challenge is a problem related to charges kept at some distance. What is the position of equilibrium? Here it is. The question given is two charges, one is positive charge, other is negative charge, are held at a separation of distance L along a horizontal axis line. A third free test charge Q is to be positioned along the same axis such that it resides in a state of net zero static force. So now here, let us consider different charges. One is positive charge, other is negative charge, are separated by a certain distance L. So where is the position where net force is zero? Some test charge is placed here at a distance x from the end A, because capital Q is positive, small q is positive, repulsion will be there. Force on small q due to capital Q will be towards right. Force on minus q due to plus q, force on small q due to minus 4q will be towards right. So when one positive charge, other is negative charge, if charge is placed in between, net force cannot be zero. Then other possibilities for us is here q charge, here minus 4q charge, where charge has to be placed. So there are two places. One is right side of B, other is left side of A. When you place test charge here, so negative charge attracts small q towards left and positive charge repulsion occurs. There is a possibility that net force is zero. Here also, here you take small q at a distance of x from capital Q. Because of this repulsion, because of minus 4q attraction, there is a possibility that net force is zero. But really, uh, at two places, net force can't be zero. Let us see why. So, where test charge has to be placed? At D or C matters. Suppose now let us put test charge at C. Then force on Q placed at C will be due to minus 4q, that is towards left, that is F1. Force on Q due to minus 4q plus force on Q due to capital Q. It will be towards left, it will be towards right. Here it is 4q by, let us say, x distance. Here it is k capital Q by d plus x. So now question arises is one is towards left, other is towards right. Is there any possibility that net force is zero? Here it is as when compare with x, d plus x will be more. Denominator is more, it will be small. When compare with 4q, it will be small. Capital Q will be smaller. So that means this never be zero because it becomes small. It becomes large. So therefore, you cannot keep the charge plus q right side of B. So the only possibility is let us put the charge at D for force on test charge, which is kept at D at a distance x from A. So then here capital Q, here minus 4q. Test charge is here. Then we get force on charge Q will be force on charge Q due to capital Q plus force on charge Q due to 4. Here it is repulsion, that is towards left. I will write minus kq by x square. This is distance d. Because of negative charge towards right, k for capital Q into small q by d plus x whole square. The net force must be 0. He is asking the position where net force is 0. So then we get kqq by x square equal to k4qq by d plus x whole square. 4q get cancelled. Sorry, q get cancelled. K, capital K get cancelled out. D plus x whole square is equal to 4x square. That is d plus x will be 2x. X will be at a distance d. That means at a distance L from the smaller charge q. Right. So this the same problem we can solve it uh, always when two different charges are there, negative, positive. Always it will be toward the smaller charge. So what is that distance means? L by q large by q small minus 1. This is the formula which you have to remember, standard model. So it will save your time. Q large will be 4q by q minus 1. That is L by 2 minus 1 L. So uh, force on test charge is 0 at a distance L from small charge q. Right? Answer is B. So I discussed concept as well.